Mohit, now coming to you, you have been the people who have actually, as NVIDIA, propelled this revolution, so as to say, because unless the hardware was there, it wouldn't have been possible today. So putting across the question back to you in terms of, what could be the innovative approaches and technologies which can address the challenge of building the foundation model? You might have solved a few, but what could be a few more which you can, give examples to this particular gathering?
As I rightly said earlier, India has around 23 official languages. But the Bharat that I am proud to represent speaks around 10,500 unique dialects across 123 unique languages. The largest model that I am aware of can deal with even 100 of languages, has a tokenizer vocabulary size of 254,000. The most popular large language model, GPT, that we talk about, even in its latest avatar, supports only 1 lakh tokenizer vocabulary limit. Any model that is required to deal with such a complexity of languages, or these number of languages, need to the bare minimum just for the spoken languages that humans speak, at least this size of a tokenizer vocabulary limit of 254,000. If you add to it the bread and butter of Indian service sector, which is the IT, the coding languages that we talk, we speak, we write, that takes us to more than around 180 languages. Moreover, my Bharat is not as comfortable in writing languages. It is more comfortable communicating through spoken languages. My Bharat speaks more comfortably than it could write. Which means now I'm not talking in the realm of the text of large language models, but I'm talking about in the realm of large communication models. Or to be more precise, large multimodal models. Just to excite your right hemisphere more, let me give you some more numbers around it. So the model that I talked about has around 254,000 vocabulary size in its tokenizer. Also is as large as around 540 billion parameters. But that model is not very popular. Because in the state of the art, if you want a model to do multiple things, and do complex things, complex reasoning, complex language translations, you require something called as a mixture of models, which is 7 to 8 models of the same size working together. So the GPT, as we know as together now, is actually 8 different models, each of size 220 billion parameters. If we are talking about a model which can understand the range of our languages, that will be around 540 billion parameter each. If we want it to do the type of tasks that we are used to with GPT and other things, we have to get 8 models of that particular size. Even at a very conservative target, we are looking at 500 billion parameters into 8, which comes to the territory of 4 trillion parameters as a total model size. Even if we take a very conservative approach, let's not take 4 trillion, let's take something in trillions. These models, as they become larger, they can learn a lot of things, but it requires data to train them. The metrics that we take data or training is, or the term is called a token. Token is not exactly the same as word, which will be coming to later. But as per some of the researchers, we require 10 to 20 times the number of tokens as the number of parameters that you want to train it to. That means we are talking about tens of trillions of tokens of data across these languages if we want an real Indian LLM that can actually do the type of task that we expect it to do. The largest open source corpus of Indian languages data that I am aware of at least runs into tens of billions of tokens only. The second thing that we talked about is about Indian culture. I don't have any problem anyone calling me black or brown or whatever color. I take pride in that. But if anyone calls me a blue painted god as white, I may have serious problems. So my sensitivities and the sensitivities of my Bharatiya might be different from the sensitivities that is aligned to the Western world. My India is large. My Bharat is even larger. When I go to travel to Bharat, even outside work, it takes me some time to start understanding what they are speaking. So in the process, I have acquired to speak at least 6 to 7 languages. If not speak, at least understand a bit and part of it. What confuses me more is, if someone starts something in Kannada, they include a local dialect of Tamil into it. I ask them a question in my broken Hindi language and confused English on top of it. Then it becomes a very complex soup. If I put this soup into even one of the most modern language models, it may not make out clear, precise sense of what I'm trying to do. People try to solve similar problems by translation. They take the English corpus or some other Indian corpus and they try to translate it into the specific language that they're trying to train it to. Research has already shown that this type of techniques doesn't scale too much. So how do we approach these many challenges in the Indian context? Now, when I went to some of the social medias, by the way, I'm also a stand-up comic, and the comic world, there's a lot of hue and cry that women, especially Indian women, especially when they become wives, speak a lot. The other trend that we see is that when they become wives, their participation in workforce come down. So God has given them a gift that we do not treat as a gift. And these are the unique opportunities when we start recognizing these type of challenges. The other approaches are more technology bound. For example, recently we launched something called a Nemotron 340 billion parameter model. Anytime a new model is launched, people will go gung-ho about it, will try to understand which other model it beats in which particular benchmark test. For the first time it happened that people were not gung-ho about that this particular model defeated or surpassed these 10 models in XYZ benchmark test, but they were gung-ho about there's a model which can generate synthetic data better than other synthetic data generator models, and that data might actually have more relaxed licensing terms in training their own large language models. So basically, if India wants to create that sort of a foundation model for its Bharat, then it's not going to be in one particular step. Research has also proved that, at least for these large language models and large foundation models, you can generate very good quality synthetic data that could be used to train them optimally to a particular ratio limits. That ratio could be 1:7, 1:10, sometimes in extreme cases even 1:100. But for that, the upstream generator model, which is generating this type of a language, should be capable to bring that sort of a diversity. Which means now we are in an iterative cycle. We are not talking about one foundation model for India, but a series of hierarchically more complex, more sophisticated foundation models for India. Just to excite your left brain even more, GPT-3, around 340 billion parameter model, not a mixture of models, but only one single model, took 10,000 GPUs running over several weeks to train that one single model. Of course, we have come a long way from there. The GPUs that they were using, now we have come to the level that we support that sort of a compression of the model, such that the same model could now actually sit on smaller number of GPUs. They are faster, we could require less model. But now we are talking about much larger models as well. So one thing that we have to get into is how much can we compress a model such that it can fit into the most recent technologies, and those most recent technologies also have to advance, and for that the research alignment between whoever is building the foundation models to whatever researchers are there should be in close conjunction such that the researcher can take a lead over there and come up with that architecture that can just not scale to a 16-bit model, but to 88-bit model, to 4-bit model, and even to the realm of what is now called as small language models or SLMs, which goes into 4-bit, 3-bit, sometimes even 2 bits. Because we are not talking about a resource-rich country where at least even the government can afford tens of thousands of GPUs. The small enterprise that has to host them might not be able to do that. The model should have these much features that it can fit to that latest infrastructure. The other challenges that we talked about is the cultural diversity. We have at least 3 members speaking about the different cultural diversities that India has compared to other languages. We also talked about safety. We also talked about sensitivities, which is very different from the Western world on which these models that we use today are trained. There is a specific process called alignment. We talked about reinforcement learning, some of the panelists talked about. That is just one form of alignment. There are multiple forms of alignment that make a model be more aligned to our sensitivities and our preferences. Reinforcement learning in itself is a computationally gigantic task. The reason why today's planning in large language models happen through large language models which are based upon transformers and not reinforcement learning, which was primarily acted as the, you can say, spearhead of the agentic environment. Anywhere you would require an intelligent agent, you'll use reinforcement learning, is because of the computational complexity. Plus, in its native form, reinforcement learning requires a lot of human involvement to grade the data, give them scores, how good, how bad it is. These are not just the real challenges for India, but each of this is a real opportunity also for India. I see one section of the media which is very paranoid about what will happen to our work culture, our jobs, if these large language models actually scale. Something that is imminent, you cannot stop. You can only delay. That too, you can only delay for the region that you are in. World will not stop for you. This is more dangerous for your jobs than finding out the alternative opportunities that these type of trends lay before you, and use the demographic dividend to open up new streams, new types of works where India can scale with them. Thank you.
Thanks, Mohit. Staying with you, if I can just corroborate on the fact that, you talked about, number one, go multimodal. That means you are suggesting IndiaAI should be multimodal, with voice as one of the major factors. Second is that relying on collected data may not be the absolutely right approach. We need to also collect synthetic data or build synthetic data, which is there. And third part of it is to look at miniaturization. Model miniaturization should be a very big research activity which should go on. And of course, the fourth one, which is more in the terms of adoption, that you cannot stop this revolution, it will happen. You know, the best way is to, you know, see the potential and see the challenges and start, you know, preparing for it and working towards it. So staying with you again, you know, the next question which I have for you is that, you know, what is your view in, you know, the challenges being faced by the startup ecosystem in working with LLMs, and how can India Innovation Mission work towards solving that? You know, that's, if you can throw some light on that.
So there are multiple challenges that I see Indian startup face. And by the way, in my role, I work with a lot of startups and a lot of different organizations of different sizes. And my role is to help them out, make a sustainable business with Gen AI and AI in general. So I see actually a lot of different startups from a lot of different types of streams into artificial intelligence. One main thing that I see is competitiveness. How these large language models are posed today favor a Western company more than an Indian company. This may seem slightly extreme, but let me again excite your left hemisphere to put these tokens. Now we talked about tokenizers, tokenization vocabulary a bit back, and we talked about GPT has 1 lakh tokens, and GPT-4 has 1 lakh tokens, and GPT-3 has around 50,000 tokens, 54,000 tokens. But even GPT-4 is trained around 23 languages. I think some are 2, 3, or max 4, 8 are in Indian languages. If you take a text, if you say take an English text, you put it into a token computation system. So many of these languages also provide you a portal on which you can compute how many words compute to how many tokens. So these models talks in the language of tokens. Any pricing or any compute that you may require, you would actually be asked one question, how many tokens you are going to deal with from an input perspective and from an output perspective. The reason is that the computation has to scale at the rate of square for each additional token. So then it matters in my language, if I'm giving it 100 words, how many tokens those 100 words would be computed to. That will determine how much cost I am going to give to take the same advantage from a large language model or a managed service or a compute from that perspective if I'm using any model that is trained on a Western language or predominantly Western language where the Indian representation is not there. Again, throwing some arbitrary numbers, you can check the exact numbers over there. These will be ballpark. So if I'm taking an English text and I'm asking how many tokens this 100 words in an English text will contribute to, I'll get roughly around 130 to 150 words, depending upon how rich those words are. This is for something like a GPT-4. GPT-3, if you put the same thing, because its vocabulary size is less, you will come to a larger limit. If you start putting Indian languages into it, even the most popular Indian languages that we know, this can go up to 3 times. If you start putting the language that my Bharat speaks and the dialects that they speak in, they can go up to 7 times. Which means my Bharat has to pay 7 times more money. And the businesses that support my Bharat has to incur that much more cost than a similar business outside for which these models are trained. Now, if I make a foundation model for India, which is trained on the languages of my Bharatiyas, not just the language of my Indians, I can substantially bring down this cost. This is just the challenge number 1 that I am talking about. Challenge number 2 that I see with the startups in India is that of sovereignty, Atmanirbharta. Again, I am making a very bold claim, a very extreme, not even a claim, but a point, but let me support it. I've heard many people here, and outside even, call some of these models as compared to GPT, the other models that we see outside, as open source models. I am not aware of any, or at least many, open source models. Open source terminology means that the source code is open, anyone can take it and build of its own. What you call as these models is an open weight model. Nobody is giving you the source code of these. They are allowing you to use the weights, and they are giving you some source code that you can use to fine tune or adjust some weights such that you can make some tasks better than the normal tasks that exist. If you see the licensing terms of these models, of course, this can change from model to model. One is that you cannot use it if you grow above a particular user, a particular amount of revenue, and so forth. There could be other terms. For example, whenever you use some of these models, you have to always tell this has been made by this Western corporation and this is the model name that we originally used. You lose your identity. The third is you cannot get into any business that competes with them. Just because my India couldn't afford a foundation model, I have to pay it through my sovereignty by adopting these terms. So right now we'll be calling it as an open model. The third type of challenge that I see with Indian startups especially is the integration between research and development skill sets. In the Western world, any of these models, the larger organization, whoever came up with these large language models, didn't came up with a very intrinsic research enterprise partnerships where most of the decisions are being taken by the research and the corporations fund them. That model in India is not very strong. It needs to come stronger. Currently, government is supporting the researchers and then giving the researchers a leeway where some enterprise at very low cost is trying to attract some of the minds, but not at the level of architectural decisions of changing the entire model and investing billions and billions of dollars into their decisions. The fourth challenge that I am seeing is on the architectural and the development landscapes. Of course, government is running programs on skilling India, but as I said, the more these models will come, we are the IT powerhouse of the world. But we are in a sad situation that for our own startups, maybe some larger corporations can afford these high-brain people, but for the smaller organizations, they are not so blessed. The type of architects and the developers that they could afford, they have to invest a lot into it to get to the level that they can deal with modern GenAI architectures, which is much different from the earlier approach of deep learning as we used to do. So the approach that I see mostly that startups adopt is, this is my problem, this is my target audience, this is a solution that I used to do with them when I was building a chatbot earlier with conventional NLP. This is a part of NLP that I want to transform into GenAI, so let me use a GenAI service either managed or through some of the open source or open model sort of a thing into it. This approach very slowly takes them into a vicious spiral where they cannot scale anymore without incurring a lot more cost than they would have taken had they taken a later approach. Which means now the foundations of the model that the biggest companies are using are at a much more advantage than even the startups. or larger startups are actually much more advantaged than at a smaller startups. This again was a decision that was taken because there were not enough people to guide them. So these are the 4 basic challenges that I see with startups in India.
Sure, Mohit. I think, the message for India AI mission in that particular case is to create the foundation models which are inherently open and also encourage the startups so that they don't lose the sovereignty and incur the cost which they are incurring right now.